China's WS engine program has just crossed a line few in the West ever expected it to reach. After decades of chasing GE's lead, China finally hit a point where even GE had to admit the progress is real. For the first time in 30 years, the balance shifted, and the impact landed directly on GE. What keeps people talking is how unlikely this moment seemed. How did a program that once barely survived end up rattling a company famous for engines with near-perfect reliability? And what changed inside China's WS family that made GE pause and say something no one expected? To understand why GE felt this in 2025, you have to go back to how uneven the fight looked at the beginning. For years, China could build airframes, radars, and missiles. But the engines tying everything together kept coming up short. Western analysts often called engines China's final missing link, and they were right. While GE and CFM powered aircraft that stayed on wing for tens of thousands of hours, China struggled with engines that sometimes failed after only a few dozen. Every new fighter that rolled out of a hangar still depended on Russian or Western engines to reach full capability. Inside China, this weakness became more than technical. It turned into a national pressure point. Leaders wanted aircraft flying on domestic engines, not borrowed ones. The early WS program was brutal. The WS-10, meant to close the gap, ran into problems that made the effort look doomed. Reports of short lifespans, instability, and sudden failures spread quickly. On one side stood GE, backed by decades of experience. On the other was a country pushing for a breakthrough with materials, processes, and skills still maturing. That imbalance defined the next 30 years. It set the stage for a long struggle between a company that dominated engine design and a state program that refused to remain behind forever. China's engine troubles didn't come from a single mistake. They came from a long series of setbacks that exposed how wide the gap really was. Through the 1990s and 2000s, China tried to replace Russian engines with domestic designs. The WS-10 was the main hope, but early results were disappointing. Some engines reportedly lasted around 30 hours before requiring work, far below the roughly 400 hours of the Russian AL-31. Engineers battled turbine blade issues, heat management problems, and inconsistent quality control. Meanwhile, GE and CFM were setting global standards. The CFM 56 powered fleets worldwide with failure rates so low it became the benchmark for reliability. China saw the numbers. The difference was undeniable. By the early 2010s, it was clear the problem wouldn't fix itself. In 2016, China consolidated most of its engine manufacturers into a single giant, the Aero Engine Corporation of China. Nearly 100,000 employees and massive funding were placed under one roof. This was no longer experimentation. It was a national mission to compete with GE, Rolls-Royce, and Pratt & Whitney. The real change began when engines finally started staying in service, flying hard, and coming back with fewer issues. Progress was slow. It took years of incremental gains, failed tests, and quiet revisions. But by the early 2020s, the pattern was shifting. The WS family was no longer stuck in the past. For years, the WS-10 symbolized how far China still had to go. Around 2020, that narrative began to change. New J-10C fighters entered service powered entirely by WS-10 engines. Soon, the same engine appeared on J-11B J-15 and J-16 fighters, and even early batches of the J-20. Later versions reached lifespans in the hundreds, then well over 1,000 hours. They still weren't at GE's level, but they crossed the threshold needed for frontline service. For the first time, China had broken out of the failure loop. Then came the engine that truly caught attention, the WS-15. Designed to give the J-20 the thrust and performance it lacked, the program faced early test stand incidents and delays. But by 2023 and 2024, a shift became visible. New J-20A prototypes were flying with twin WS-15 engines, with reports pointing towards serial production. The message was straightforward. China now had a domestic engine for its top fighter. At the same time, the Y-20 transport fleet began flying with WS-20 engines, replacing the Russian D-30s used for heavy lift. This wasn't just an upgrade, it ended a long reliance on foreign power plants for strategic transport. Another step followed with the WS-19, aimed at the J-35 carrier fighter. That placed China in direct competition with engines in the same class as the GE F-14. The signal was clear. China wasn't trying to compete in just one category. It intended to compete across the entire engine spectrum. By this stage, it was obvious. The WS family was no longer a liability. It was shaping China's fighters, stealth aircraft, and transport fleets. And that progress was about to land harder on GE than anyone expected. The turning point came in 2025, not in a test facility but through policy and supply chains. In May, the United States suspended export licenses for two engines critical to COMAC, the LEAP-1C and the CF-34. These engines powered the C919 and C909 programs. The suspension triggered delays, rattled airlines, and sent pressure straight into GE's business. For years, GE had sold engines into China with relative stability. Overnight, that certainty vanished. Engines became leverage in a broader political fight, and GE found itself in the middle. In July 2025, the suspension was lifted and shipments resumed. On the surface, it sounded like a win, but the damage was done. Engine access could now be turned on and off at will. GE had seen the future, and it looked unstable. Inside China, the lesson was clear. If a single external decision could disrupt aviation plans, domestic engines were no longer optional, they were essential. The real shock came shortly after. At an industry event, GE executive Steve Russell made a statement few expected. He said Chinese military engines were catching up. Not equal, not leading, but no longer far behind. For a company built on engine dominance, those words carried weight. At the same time, new images showed J-20A prototypes flying with WS-15s, Y-20 transports using WS-20s, and J-10C fighters operating reliably with WS-10s in growing numbers. The progress wasn't theoretical anymore. It was visible, operational, and impossible to ignore. The proof was visible in the sky. China was now flying what it built itself. That was the moment the decades-long balance finally shifted. Not because China had matched GE in every category, but because China no longer needed GE to keep moving forward. And from that point on, the stakes only grew higher. Why this shift matters becomes clear once you understand how much power jet engines give a country. They are not just components on fighters or transports. They determine how far a nation can project force, how fast it can respond, and how long its aircraft can remain airborne. For years, China had modern airframes, avionics, and radar systems, but its engines kept it dependent on others. With WS engines now powering frontline fighters and the Y-20 transport, China no longer has to rely on Russia for thrust or on foreign supply chains for critical parts. This is not a minor change. It reshapes how China can plan for the next decade. A country that once had to time its ambitions around foreign engine deliveries can now set its own pace. For many years, GE held an advantage that seemed secure, even as China improved its aircraft designs. GE engines remained the benchmark, giving the company influence, steady orders, and a strong position in China's commercial aviation market. But once the WS family proved it could handle real-world missions, that sense of safety began to fade. This does not mean China can replace GE globally today, but the long-term picture has changed. China can now deploy fighters and transports powered entirely by domestic engines. That means testing, upgrades, and new variants no longer require foreign approval. Military planners can move faster, revise designs more quickly, and make decisions without worrying about external supply lines. That freedom affects everything from patrol planning to long-range operations. China still depends on foreign engines for its airliners, especially the C919. But the progress of the WS family and the rise of the CJ programs make China's direction clear. The country does not want a future where a single export license can slow down its entire aviation sector. The more successful the WS engines become, the stronger the push grows to build commercial engines that can stand on their own. This is why the moment hit GE so hard. The company has led the industry for generations. But for the first time, it is facing a rival that does not plan to buy its engines forever. China wants to build engines for its military, its airliners, and eventually for other countries willing to take a different path from the West. That ambition is reshaping the global engine landscape, and its impact is only beginning to grow. From the outside, the rise of the WS engines can look smooth. But the road behind it was filled with problems that shaped the program as much as its successes. These details are rarely highlighted in official coverage, yet they explain why skepticism lasted so long. The earliest WS-10 engines were not just underperforming, they were risky. Reports from the 2000s described engines failing after short flights, losing thrust, or suffering sudden surges. Entire batches were rejected by the Air Force. Training schedules were disrupted, missions delayed, and aircraft left grounded because the engines simply were not ready. These issues raised serious safety concerns and slowed China's fighter programs for years. Poor reliability affected more than hardware. Engine failures during training increased risks for pilots and placed heavy strain on maintenance crews. One unreliable component could ground an entire unit. Even when these problems stayed out of public view, they deeply influenced how the military viewed the WS program in its early stages. The rivalry also spilled beyond engineering. It moved into court cases and headlines. U.S. investigations linked stolen GE turbine data to groups inside China. The Turbine Panda campaign targeted suppliers connected to the C919's engine systems. These events damaged trust and added another layer of tension. For China, they highlighted how far it still had to go. For the U.S., they showed how determined China was to close the gap. The 2025 export suspension exposed how fragile the commercial engine relationship had become. Airlines faced delays. COMAC slowed production. GE risked missed targets and shaken confidence. When the suspension was lifted weeks later, it only reinforced the lesson. A single decision in Washington could disrupt the entire supply chain. Any one of these setbacks could have derailed a smaller effort. Instead, they strengthened the push behind AECC. Every failed WS-10, every delayed test, and every export shock pushed China further toward independence. The controversies did not slow the story. They shaped it and set the stage for the moment GE could no longer ignore. This is where the long climb began to pay off. After decades of failures, retries, and quiet improvements, China reached a point where the sky itself looked different. Fighters that once depended on Russian engines were flying on WS power. Transports built around foreign designs were lifting off with domestic engines. And the J-20, China's top stealth fighter, was testing with the WS-15, the engine the program had pursued from the beginning. For the first time, China was not following someone else's path. It was moving on its own. Then came the confirmation. GE, the company that had defined the standard for years, acknowledged that Chinese engines were catching up. Not someday, not in theory, now. That single statement showed the world that the race had changed. China had not matched every metric, not yet. But it no longer needed foreign engines to keep its most important air force moving. That shift sent a message across the aerospace industry that could not be undone. The rise of WS engines does not mean China has surpassed GE. GE still leads in fuel efficiency, durability, and long-term reliability. But that is not what is shaking the industry. What matters is that China no longer depends on outside engines for its most critical military aircraft. That freedom changes how a nation plans for conflict, competition, and the next phase of aviation growth. From here, GE faces a new kind of rival, one that is not trying to purchase engines, but to build its own future, one that can test, refine, and upgrade without waiting on foreign approval, and one willing to invest for years without worrying about profits or shareholders. This is why the shift matters. Not because China closed every gap, but because it closed the one that held it back the longest. For the first time, both sides are entering a phase where the old rules no longer apply, and the story is not finished. The next chapter is already taking shape in China's factories. The CJ programs are moving forward, and each step brings China closer to powering its airliners without Western help.